Hello students, welcome to our classes, and we are going to start with something that is very important for multiple exams. Okay, and that is functional analysis, and we are going to start with the revision of functional analysis, as you already know a lot about functional analysis. So let us start. The first topic would be, let x be a vector. Let x be a vector space, of course, over a field f of numbers, and the field f is equal to real number or complex number. Okay, anyone, it can be a field of anyone. Then a norm, okay, a norm on a vector, then a norm on a vector space x is a real valued, okay, function on x if it satisfies a few conditions, and the conditions are this. Condition number 1, okay, is a function on x. First of all, before that, let's write this. Okay, norm, okay, that is x to r. Okay, so this will happen which satisfies which satisfies the following conditions. Satisfies the following conditions. And what would be the conditions, students? Let's go ahead and write the conditions. Even maybe you already know it. The first one is the norm of x is greater than equal to 0. The second one is the norm of x is equal to 0, that is same as x is equal to 0. The third one is norm alpha x, okay, is equal to mod alpha norm x. All right, then the fifth condition, the fifth one to satisfy, is norm x plus y is equal to norm of x plus norm of y. Okay, for all x comma y belong to capital X, comma alpha belong to f. Okay, so you see, when these conditions are satisfied, okay, then a few points on this would be, second point, a vector space, okay, a vector space x with a norm defined, on it, is called normed space. Normed space or normed linear space, or sorry about that, or normed linear space. All right, students, and the third one is a complete space, is that in which, okay, complete space is that in which the Cauchy sequence is convergent. The Cauchy sequence is convergent. Okay, and the fourth point would be a norm of x defines a norm of x defines a metric D, defines a metric D on x. All right, it defines a metric D on x which is given by D of x comma y is equal to norm x minus y. All right, such that x comma y both belong to the set X. All right, students, so that's it for this part of vector analysis, functional analysis. Okay, since we are writing vector, I forgot. Okay, so functional analysis, so we spoke about vector space. So let us continue with this in the next video, students. So thank you for watching. See you next time. We will continue from the point number 5. Bye bye.